Hello, Mr. Malo here, your online math teacher, and welcome to my channel. Today we're going to be continuing my video series on confidence intervals, and in particular looking at how to calculate a 95% confidence interval using one sample proportion. So if you find this video helpful, consider smash the like button, subscribe, and let's go. So in my previous videos I talked about why you might want an interval, as well as the differences between confidence level and confidence interval. But I didn't talk about how to construct your confidence interval. So we're going to do that today. Here's the scenario. A student at a large university wants to study the GPA of full-time enrolled students. The student takes a simple random sample of 72 full-time enrolled students and finds that 40 of the 72 students report having GPAs above 3. So we want to construct the 95% confidence interval to estimate the proportion of full-time enrolled students at this large university with a GPA above 3. So that's what we want to do. Now, this is not going to be much different if you have a different confidence level than 95%. I will tell you where it would differ here, but let's jump into it. We are going to use the state, plan, do, and conclude criterion. So if you are taking an AP Stats class, this is what is going to be expected of you. It's also a good way to organize your thoughts to make sure you hit everything you need when you are constructing these intervals. So the first thing we need to do is focus in on this state portion. So what is the parameter we're looking to find, and what is the confidence level we're interested in? In this problem, and in most of these, they're going to be reasonably straightforward. So what we're interested in is the true proportion of full-time students enrolled at this university with a GPA above 3. That's our parameter we're interested in. We don't know it. And the confidence level is 95%. So this is the state phrase. What's our parameter and what's the confidence level? Now we need to come up with a plan. Well, the main things of the plan are what procedure are you going to use, as well as are the conditions met to follow this procedure to construct our confidence interval. So the procedure we're going to use is one sample z intervals for proportions. So z as in z-score. So we're hoping things are normal here, like normal. Then the conditions we need to check are randomness, the 10% condition, and the large counts condition. So we'll start with randomness, because we need randomness if you want to generalize what you observe from your sample to the entire population. You want to make that inference. So, in this case, we had a simple random sample of 72 students, and simple random sample has random in it, so that is a big check mark for us. We have satisfied that random condition. The second thing we need to look at is the 10% condition, and in this case, 72 is definitely going to be less than 1/10 of all full-time enrolled students at a large university. If it was maybe a tiny university, maybe we'd fail it, but large university tells us we are good here. And this 10% condition is what lets us be able to use our standard error formula, which we're going to talk about in a second. So that's what the 10% condition is going to let us do. Then finally, we have the large counts condition, is the expected number of successes and failures, both at least 10. And since I don't know the population proportion, because that's what I'm interested in, I'm going to use my point estimate, so that sample statistic of 42 out of the 72 students. Or sorry, 40 out of the 72 students. And when I do that, I get that I have 40 expected successes and 32 expected failures when I'm doing this. So I have satisfied the large counts condition. So I've met all my conditions, and the large counts condition is what's going to assure to us that the probability distribution we're looking at to construct our confidence interval is approximately normal. So now that we've checked the conditions, we are good to move on from the planning stage to the doing stage, because our conditions are met. So what we're really looking to do in this stage is to compute the point estimate plus or minus the margin of error, otherwise known as the sample statistic we've obtained plus or minus the critical value times the standard error, which is really just the standard deviation formula you learned back when you studied sampling distributions, but since you don't have the population parameter, you plug in our sample statistic here. So let's do exactly this. So the two things we need to start off by finding, because we already know that we have our p hat, we will start by finding the standard error. And we could do standard error or critical value in whichever order we want, but we're going to start with standard error because it's the most straightforward. It's just plugging into this formula. So the standard error here, we are going to compute is just the square root of that sample proportion. So 40 over 72 times 1 minus 40 over 72, all divided by our sample size of 72 here. So you can plug this into your calculator and we can get a good estimate of our sample error as, or standard error, sorry, as 0.059. So I'm just going to write that over here, 0.059. So now I have my standard error. Next up, I need to find this critical value. So what this critical value is, and this is where the 95% confidence comes in, it relates to the following picture. If I have my standard normalized distribution, so standard normal distribution here, I want to find what are the z values on either side of our mean of 0 here, so a standard or a z-score of 0, such that 95% of the area falls between them. I'm going to call this higher number z star, that's our critical value, and the lower number is just going to be negative our critical value. So you have two ways you can easily go about finding this, and this 95%, just change it to whatever or confidence level you want. It's going to be the same process. You need to do it two ways. You can either use a table. In my case, if I use a table, I'm going to use the fact that I know that in this tail, there is 2.5% of the area. So what I would do is I would go to a table, such as this one here in the provided my AP formula sheet, and I'm going to look for an area in my table to the left of a z value of 0.025. And I'm going to notice that this area that I can find is roughly corresponding to the z-score of negative 1.96. So my lower bound in this picture is negative 1.96. My upper one is going to be just 1.96. And we'll say that our critical value in this case is 1.96. And this is the only place this process really differs as far as confidence level is concerned. So your percent of area in the tails will change. You can do this with technology also. There's nothing wrong with that. But this is how you could do it with the table. And I'll make a video later on how you could do that. Although this is really just using your inverse norm function if you have a TI-84 calculator. So now we have all the information we need to calculate our point estimate plus or minus the margin of error. So what we have is the following. When I take my point estimate of 40 over 72 and add the standard error, which is me multiplying my critical value and the standard error, my margin of error, I get 0.67. If I have 40 over 72 and I subtract off the margin of error, which is just the critical value times the standard error, I get 0.44. So what this tells me is my 95% confidence interval is from 0.44 to 0.67. So I have now completed the do phase of my problem. And if you want a different picture than the one I drew here, this is the picture my confidence interval really gives us in terms of our probability distribution. You're just looking at a normal distribution with our mean being that sample proportion of 40 over 72 and your standard deviation, it being treated as our standard error. And we can see our 0.44 and our 0.67 and around it. So what we want to do now is we always want to conclude, which means interpret our confidence interval in the context of the problem. And since my 95% confidence interval is from 0.44 to 0.67, I'm going to interpret it as we are 95% confident that the interval from 0.44 to 0.67 that we just computed captured the true proportion of full-time students at this university with a GPA above 3. So this is my conclusion. It is my interpretation of that 95% confidence interval. So as you can see here, this is all the work that you would need to put into this problem. The state plan do conclude gives us a nice flow through it. Now, if you're taking AP stats, you are in luck in that in your formula sheet, you are given that if you're interested in inferential statistics, so sampling distributions for proportions, and we know that our standard error formula is right here. So standard error is given for you right there, although it's really just the standard deviation formula from before, just with our little sample statistics now in it. So I hope you found this video helpful. If you did, consider smashing that like button and have an awesome day.